So I think we're on the back of worksheet 5. Does that sound like where we left off? Did we get through, we were looking at 9? Did we get through that one? Okay. We didn't do 9, okay. On number 9, it's really talking, it says, a curve on a highway has a 1,000-foot radius with lanes that are 14 feet wide. The curve makes a 180-degree turn. How much longer is the outside edge of the far lane than the inside edge of the closer lane? Most of you drive, I don't know if all of you do, but maybe you've noticed when you're driving, but it's considerably shorter to be on the inside lane, right? Okay. And we're going to figure out how much shorter real quick on this question. If I can get my tablet to work. What are we talking about when we're talking about distance? What is this called in terms of all those definitions? The top of the blue sheet has all the formulas, guys. What is this called? It's a piece of the circumference, but it's actually called what in the terms we're using right now? Somebody said it. Well, it's an arc length. Does that sound familiar? Part of the, so we want the length of this arc and the length of this one, and we want to find the difference. The formulas we are given for arc length is S equals R theta. Well, we know what R is in both cases. The radius is 1,000, or here the radius is 1028. Each lane is 14, and it wants the far edge over here. That's the way I treated it anyway. That's why I kind of put numbers on here so that we could all do the same thing because it was a little unclear. Then we're supposed to put in theta times theta. Well, what is theta, guys? Okay, is theta 180? Can theta, what does it say in this little box here somewhere? At the title, it says arc length, area of sector, angular linear velocity. Then what does it say behind that? Theta must in radians. These formulas only work if theta is in radians. So what do we have to do to 180? Change it to radians. I hope you don't need to do dimensional analysis, because I hope you already know that 180 is just pi, right? So these are the two arc lengths, and we need to find the difference. So real quick, type in 1028 pi minus 1,000 pi. And tell me how many feet that is roughly. While you're doing that, I'm going to open my calculator because it takes a while. Somebody's going to shout me out a number. I don't care, foot is fine even. 88? You can put to the nearest tenth, I don't care, but did someone else get that answer? Okay. So that's a lot of distance, right? 88 feet? It's like 30 yards on the football field that you've traveled extra. All right, moving on. On the next page, we learn a new formula. This is about sector. A sector of a circle. It's on your blue sheet. It is the formula that says A equals 1/2 r squared theta. Okay? Again, it only works if theta is in radians. But what is a sector? And what does A stand for? Well, A is area. Is everybody okay with that? And then sector is like a piece of pizza or a piece of a cake or something. It's an area of this wedge. Everybody good? Sector of a circle? So we have this question on worksheet 6 that says Jaden is planting a circular garden in her backyard that will have a radius of 10 feet. As shown below, what area does she use for tomatoes? So what do we know about tomatoes, guys? Is it just this one 50-degree one? Okay, so we have 50 degrees. Can we use degrees in that formula? A equals 1/2 r squared theta is the formula. But I can't use degrees, I have to make it to radians. So what do we have to do? Yeah, pi over 180, which would just be 5 pi over 18, or you could give me a decimal, it doesn't matter. But we're gonna plug it in up here. So for finding the area, we're gonna have 1/2 or 0.5 times the radius of 10 feet squared times 5 pi over 18. So type that all in. Can you guys even see? I just think he's not that tall. Certainly did not mean to leave it right there. Does anybody know if you should be in degrees or radians, or it doesn't matter? This is a very important issue. Doesn't matter. The only time it matters what mode you're in is if you're typing sine, cosine, or tangent. Otherwise, it doesn't matter, okay? If you're not hitting sine, cosine, or tangent, it does not matter what mode you're in. All right, what'd you get, guys? 33.6? 43.6 square feet. B says, what area does she want to use for wildflowers? We need a little geometry here because she's planting wildflowers over here and over here.
Wouldn't we just get rid of the half we used throughout the area? You know, sort of?
We could. Yeah, we could say, I'm going to do this one and double it. That would work. I was just thinking we could say each of those would be 80 degrees worth. Does that make sense, guys? So she's doing 160 degrees worth, but that's the same difference as doubling one of the 80s. So either way. But the radius is still 10. And if I do 160 times pi over 180, since I'm just going to type it in anyway, I'm just going to write it down that way and type it all in. Don't forget the squared. I got 139.6. Anybody? No? Did I do something wrong? Okay. That's what you got? All right. I'm going to skip part C to save time. Did you do squared? This should be, the squared should be out there. What did you type? Can you look at your calculator screen and tell me what you typed?
10 squared times 4 over 9 raised pi. I reduced it.
Yeah, but he didn't do the 1/2. Did you type in the pi?
Oh, no, he was right. It's it should be over 9 number.
But I did the 1/2.
No, I reduced that one to 4 over 9. It's supposed to be 8 over 9.
Times it by 4 pi over 9. Nah.
I gotcha. But if he left off the half, it's the same difference as what we did. I think you didn't put the pi in, but anyway, moving on. This is the kind of question that could be on the quiz more. Well, there could be one of those, but it's just asking you the area. One type of wind turbine blade is 27.1 meters long. So we're talking about this. So when it's spinning, what is that distance called? That'd be the radius. Everybody okay? If the blades of the turbine are rotating 28.5 revolutions per minute, what is the angular speed and linear speed? This is what's going to be on the quiz, okay? Angular speed. What did you learn yesterday about angular speed? Anybody know anything?
English.
Angular speed, what letter is it? That weird W. And it's got to be radians per time. Do we have an answer in radians per time already? No. But can we take that 28.5 revolutions per minute and just do a little smushing with it and end up with radians per time? How do I change revolutions to radians? Okay, 1 revolution is 2 pi radians. Now revolutions is gone, and I get an answer. So 28.5 times 2 is 57 pi. Or if you type the pi in, it's 179.1. Now it's radians per minute. And it wants the linear speed. To find the linear speed V, anybody remember how we did that? Is there a formula on the blue sheets? So I could put 57 pi was my angular, I'm just keeping it exact, times the radius of 27.1 meters, and I'm done. 57 pi times 27.1 is 4852.8 meters per minute. Now, as long as I don't tell you the label, whatever label's most convenient is fine, okay? If I had said you had to do centimeters per second, then we got to do some work, right? Did someone else get that number? We all good? All right, 12 is very similar. A centrifuge is used to separate fluids. It is spinning at 400 pi radians per second. Ooh, nice. What is that? If it's in radians per second, it is currently an angular velocity. Part A says switch it to revolutions per minute. Oh, fine. It's just a dimensional analysis question. What are we going to do here? I want to get rid of radians and end up in what?
RPMs.
Yes, rotations. So radians got to go down here, rotations up here. What do you know about a rotation?
Have as many radians.
No. One rotation is 2 pi radians. What did we learn yesterday when we put 2 pi in the denominator? Yeah, you can just divide them out, but if you're going to put it in your calculator, you got to put it together. Otherwise, it'll do divided by 2, but multiplied by pi. Put the pi on top. All right. Got rid of radians. I have rotations per second, but they wanted minutes. So seconds goes on the top. Minutes, I'm looking for, what am I going to put there? 60 seconds is 1 minute. Seconds divides away. Like Martin said, we can divide this so that we don't have to type the pi in the calculator at all. 2 pi goes into 400 pi 200 times. So 200 times 60 should be 12,000 RPMs. Did anybody get that? Okay. Part B says, what is the linear speed 8 centimeters away? 8 centimeters away from the center is talking about a radius. And to find a linear speed, we do angular speed. But what is the angular speed? Is it 12,000 RPMs? No, it's got to be in radians, so it's got to be that 400 pi radians per second times 8 centimeters. They didn't say they needed in minutes, so I'm just going to leave it in seconds. This would be 3,200 pi centimeters per second, because magically radians goes away, remember? Or 3,200 pi is approximately 10,053 centimeters per second. Okay, I can't write. Okay, that's a big hot mess. Close? Everybody okay? Is there one more of these? All right. Real quick, last one. If it's turning, this is actually the question on the quiz, I think. This many RPM and the radius is 6 inches, what is the linear velocity? What do we need to do first? Can I use revolutions per minute? No. So how do I change 2,800 revolutions per minute into an angular velocity? One revolution is 2 pi radians, which gives me 5,600 pi, don't lose pi, radians per minute. At some point I have to change to feet per second, but the formula for linear velocity is angular velocity of 5,600 pi radians per minute times the radius, which is 6 inches. Now what do you want to do to make it feet per second? Don't say cry. 1 minute is 60 seconds, so that'll get rid of minutes. We also want feet though. So inches needs to go on the bottom, and what do you know about feet and inches? Thank you. I was kind of scared. No one was answering. So multiply all the way across the top and then divide by those two things. So on the top, we get 3360 times pi. That's not right. There's another 0 in there. And on the bottom, 60 times 12 is 720. I got 46.7. Anybody? Did someone else type it after did I put the pi in? No, I didn't put the pi in. And you can't do that, guys. Don't round into this answer without typing the pi in. That's bad practice. If it's not exact, we should type the pi in anyway. So times pi, that's a mistake everybody makes, but it shouldn't be one I make. 146.6. Okay. So I typed this all in the calculator, including the pi. If you wanted to leave it in terms that 46.6, this is not proper. You would have to do a math enter, which mine doesn't want to do. Anyway, you'd have to just reduce this. Don't leave it like that. Okay. You should now be able to finish all of this. On the homework check sheet you picked up today, I need you, everybody paying attention? On the homework check sheet, what I need you to do, here I can pull it up real quick here, I think. This is what it looks like. I need you to cross this line out down here that says the graphing worksheet. Just lightly cross it out and write special right triangle worksheet instead. We are going to do graphing, but I'm not going to collect it because it's not on this quiz yet. So cross that one out and put special right triangle worksheet. Okay? You need me to go back to the one we just did? 146.6 feet per second. All right, any questions on those? Right, then I am jumping to the special right triangle worksheet real quick. I don't know what you know about, what you remember, where this all came from. The special right triangle, the first one is the isosceles right triangle. Do you remember isosceles meant two sides the same? Well, if you have two sides the same and you have a 90, this is the worksheet that was given out yesterday, then each of these are 45. Does that sound familiar? Because they have to be equal as well. All right, so there's a little pattern that says, if that's true, if I don't know this side or this side, I could do Pythagorean theorem. I get 2x squared. Is everybody okay that x squared plus x squared would be 2x squared? And that would be the hypotenuse squared. If I square rooted both sides, I would have the hypotenuse is actually square root of x squared would be x, square roots of 2. So this is the pattern you should have learned in geometry. Does that look familiar? Or sometimes it's written leg times the square root of 2. Everybody good? Okay, I just want to show you where it came from. It came from Pythagorean theorem. So we're going to use it real fast. So tell me about number 2. If the pattern says the legs are the same, then which one's 14? Y is 14. And the hypotenuse is 14 square roots of 2. Number 3, if the hypotenuse has 7 times the square root of 2, then each leg has to be 7. Those are the easy peasy ones, right? Then they get more complicated. What am I going to do with square root of 10 over 2? Well, that's a leg, right? So it also goes where y is, because the legs are both the same. And how do you find a hypotenuse? You take one of the legs and you multiply by square root of 2. Okay, help me out. What do we get on top? Square root of 20 divided by 2. Can I take 2 into 20? No, because one's in the radical and one's not. But what is the square root of 20? 4 times 5. What's the square root of 4? And now can I divide that 2 out of there? So we end up with just square root of 5. So this is the idea that got us to there. It was leg times square root of 2. Okay, over here, anybody remember how we do this?
Square root of 2 over 2.
Well, we got to talk about that. Let's think about why. What's happening? This is supposed to be m or n times the square root of 2, right? One of the legs times square root of 2 equals 2. So if I divide both sides by square root of 2 to figure out what m is, I get m is 2 over the square root of 2, which when I rationalize becomes 2 square roots of 2 over 2, which is square root of 2, like Xavier said, but I want to make sure we get it. Go to the back and just tell me about this one, guys, 18. It's a 45, 45, 90 again. It's a 20 here. So that 20 is supposed to be leg times square root of 2, right? So that's the process we just did. 20 divided by square root of 2 is 20 square roots of 2 over 2, which would reduce to what? Yeah. All right, back to the front. The other pattern has to do with an equilateral triangle. When you have an equilateral triangle, all the angles are the same and all the sides are the same. So the angles are all 60 and the sides are all the same. That isn't very helpful when we're doing 90-degree triangles. So what we have to do is cut that in half, okay? So if this is a 60, 60, 60, all of these are the same length. Now we could make them X, X, and X, but it turns out it's easier if you call them all 2X, because then when you cut it in half, this stays 2X, but what's this guy down at the bottom become when I cut it in half? 1X. We don't like fractions as any more than we have to. Otherwise, we'd call that X and this one half X, but that's an extra fraction we don't need. But to find this missing leg here, I'd have X squared plus that leg squared equals the hypotenuse squared. Well, help me out here, guys. What's 2X quantity squared? 4X squared, right? Because it's 2X times 2X. So then if I subtract an X squared, what do I get? 3X squared. So then if I square root, each leg is, or this leg that I'm looking for, the long leg, X square roots of 3. So that's where it comes from. It does come from Pythagorean theorem and the fact that an equilateral triangle has all equal sides and a 30, 60, 90 is half of an equilateral triangle. What you need to know and have memorized, whoa, sorry, that's a mess, is the hypotenuse is 2X, or 2 times the short leg, where the short leg down here is X, and the long leg across from the 60, that's how we determine it's the long leg, is X square roots of 3. That is the saddest looking triangle ever. I'm gonna give it a little face, it's so sad. All right. Number 7 then. If the long leg has already a 7 times the square root of 3, what does that tell us? Where's the 7 go? The 7 is the short leg, which goes where? Down here. And this is 14. Okay, what happens if we know the short leg is 4? A would be 8 and B would be 4 square roots of 3. This is on the quiz. It's very important. Okay, now it's getting a little messy because the hypotenuse cut in half is going where? This is 2 times the short leg. So 11 over 2 goes up here for the short leg. And once I know the short leg, what do I do for here? Multiply by square root of 3, so I get 11 square roots of 3 over 2. This is the ugly one, because 13 is the short leg v times the square root of 3. So what do we have to do to work backwards and find v? Look at the algebra here, guys. We just got to divide by square root of 3, right? Well, what's that going to become? So we have 13 square roots of 3 over 3. Now, how do we get to u? This is 2 times the short leg, right? So that's that disaster we just did doubled. What's 13 square roots of 3 over 3 times 2? Yes, 26 square roots of 3 over 3. Just the 26 is doubled because it's multiplying by like 26 over 1. Are we on the back yet or not? Okay, then I'm going to let you do the rest for practice. It is part of the homework check, and yes, the answers are at the bottom. We good? Okay, this brings me to the fun unit circle portion of the day. Okay, you have to have the unit circle memorized. I don't have the touch stuff plugged in, and I want to be able to stand up here and do this. I don't know if it's gonna let me suddenly connect. I saw it blink. Did anybody else see it blink? Doesn't always mean it's gonna work though. Of course not. Needs to be calibrated maybe. We'll give it one try. Just turn the page. Turn the page. Is there another way to turn the page? Okay. In degrees, these are all the special right triangles, so you should all be able to fill the degrees in pretty fast. Do you remember this? Okay, this side's angle is 30 degrees. So where's another 30-degree multiple? Okay, this is a multiple of 30, but it's going backwards from 360, right? I would just, this is a 30, to here is another 30, to here is another 30, you good? So all the way around, skipping these middle guys, because those are going to be the 45s. So 30, 60, 90, 30 more is 120, 30 more is 150, 180, 210, 30 more is 240, 270, 300, 330, and 360, or 0. Everybody good? You can do that part? Okay. Then you go back and you hit up to 45s. 45 times 2 would be 90, but another 45 is 180, another 45,
225.
another 45, another 45. Everybody okay? You can do those? All right. So the degrees we got down. That takes us to the radians. Now this is where it gets real tricky for students, but I'm going to teach you just do the multiples the same way we just did. Okay, so you had a 30 degrees, you did this, and you went, so pi over 6 was 30, right? Now just count by pi over 6's. 1 pi over 6, 2 pi over 6, what is that going to reduce to? 3 pi over 6, which is going to reduce to 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, right? Be careful. 11 pi over 6 doesn't reduce. This was 0 or 2 pi. Feel like you can do that pretty fast? Because you do have to do this stuff in a timed situation. Okay. Now we got to go back and do the 45s. And you don't get a calculator, by the way. 45. This one I would memorize because it's not one that reduces in your head real easy, but how far to wait, if this is pi, this is half a pi, this is what?
1/4.
Yes. So then you have 1/4, 2/4, because that's the next 45, right? 3/4, 4/4, 6/4, 8/4 is 2. So the radians, you got that? Can you do that pretty easily? That shouldn't be a problem. Okay, the next part is the tricky part. What time do I have? Oh, I got time. Okay. The next part is where students get all messed up. Okay? they get these backwards. Most of you can remember that there's a 1/2 and a square root of 3 over 2 and a square root of 2 over 2 somewhere, right? But do you see this blue length in this spot right here at the 30 degrees, right? Because it's 30 degrees here. It's just labeled out there on the picture, or on the unit circle. It's 30-degree turn right there. The blue one is longer than the red one. Are we good? If you can remember that x is longer than y right there. Is that x more than that? Square root of 3 is like 1.7, okay? So if you can remember, or if you draw your 30, 60, 90, real quick on your paper, remember this is how it goes. So opposite would be, I'm sorry, first one is cosine and then sine. So cosine would be adjacent over hypotenuse or square root of 3 over 2, and sine is opposite or 1/2. Whatever helps you, okay? Or you could put numbers in there, find what's opposite, etc. What do you think? Did you do that one? Now, that one repeats, that one right there repeats where? Where's another one exactly that size? Right here, right? So this is still going left the same amount, but it went left, right? Now there's two more. Down here, it went left and down. And down here, it went right and down. But all four of those are the same size, yes? But there are actually four more that are the same size. They're just drawn backwards. Do you see how the blue and the red switch when you go up to 60? It's shorter over and longer up and down, right? So this time I went over only 1/2, but up square root of 3 over 2. And I do the same thing over here. Which one's negative in this quadrant? I went left, and here, and here. I went right. Did I just write that one backwards? Yes, I did. Okay. I went left only 1/2, and down square root of 3 over 2. And here I went right 1/2, and then down square root of 3 over 2. That's how I remember them, is just which one did I go further, left or right, up or down. And then 45, 45, 90, they're equal, right? X squared to 2. So if I divide them all by the square root of 2, or I think of it as sine, cosine, tangent, it's going to be 1 over square root of 2. Most of you just memorize it. What is it? What's that other ordered pair? Yeah, square root of 2 over 2, and it's got to be the same, right? Because it's a 45, 45, 90. So then you just put that all the way around in those four spots, except you change some signs, yes? Etc. I'm going to run out of time. No, I'm not, but I'm running out of space. Can you put that all the way around? Okay. What does that leave? What have I left off? There's some ordered pairs I didn't put on.
90, 270.
Yes.
80.
The unit circle, okay, is a radius of 1 unit. So therefore, this was what? On the x-axis, this is over 1 and up 0. This spot up here is over 0, but up 1. Left 1 and up 0. And down here I have across 0 and down 1. I have to say this. I write them backwards all the time. If I don't, in my head I have to say, am I going left, right, up, down? So, okay. You think you can do the unit circle now? That help anybody? There are all kinds of videos on YouTube to help you learn it as well. One of the videos that kids have shown me in the past goes through real fast and, well, it does the same thing I did here as far as this is 0, 30, 45, 90. Most of you learn the degrees pretty fast. But then what it does out here is it says, this is up 0, this is up 1, this is up 2, and this is up 3. But this is square root of 1, which is 1. This is square root of 2, and this is square root of 3. Because remember, it's getting shorter. I'm sorry, it's going up further. And then they're all over 2. And then as far as over, you went over pretty far, so that's the 3, 2, 1, and then you square root. The other thing is there's a hand thing you can do where you put your hand like this, and, no, is it your right hand? And if I'm pointing to this one, it's 1 and 3. If I'm doing this one, it's 2 on either side, so it's 2 and 2. If I do this one, it's 3 and 1, so then it's something like that, weird. Huh? Okay, it's no calculator, and it's, I don't know, like 7 minutes? I don't remember how long we gave. The other thing you have to do is you have to put the signs on, like which quadrant is the sine, cosine, tangent, positive or negative? But we can go over that tomorrow. Okay, there is practice. Where in your packet, guys?